Hi developers, and welcome back. Today, we're diving into the world of Java Virtual Threads, a new feature introduced in Java 19. We will explore what they are, why they were created, and how they work with a practical example in this video. Let's roll the intro. What is a disadvantage of using platform threads for blocking I/O operations? Consider a platform thread, and there is a database. The thread sends a request to the database at 0 millisecond. The database took 199 milliseconds to complete the operation and sends the response back at 200th millisecond. Now, the platform thread remains idle during the time in between after sending requests to the database and before receiving the response from the database. This scenario makes the thread costlier. How virtual threads are executed on top of platform threads. Consider two platform threads, thread 1 and 3. Platform thread 1 is executing a virtual thread 2 initially. Now once the virtual thread 2 goes into the waiting stage, due to any blocking I/O operation, the virtual thread is moved to JVM heap memory. Also, the next virtual thread 1 is executed in the platform thread 1. Once the response signal received from the blocking I/O operation in virtual thread 2 in the heap memory, the virtual thread 2 will be moved to any available platform thread to execute further. In this case, it is platform thread 3. This is how virtual threads work with platform threads. What are virtual threads? Regular threads, also known as platform threads, are the traditional way to handle concurrency in Java, but they come with limitations. Creating and managing too many threads can consume system resources, leading to performance issues. Virtual threads are a lightweight alternative that address these limitations. They exist within the Java virtual machine and are mapped to a smaller number of platform threads. This allows you to create a much larger pool of virtual threads without overwhelming your system. When to use virtual threads and when not to use it. The cost of running a task in a virtual thread includes the cost of running the task in a platform thread, plus an overhead. So it is more expensive to run a task in a virtual thread than platform thread. When is using a virtual thread an advantage? The cost of blocking a virtual thread is very much lower than the cost of blocking a platform thread. So running a task in a virtual thread is an advantage only if it is a blocking task. Running a task which has only in-memory computations in a virtual thread is useless, as it degrades the application performance. Creating and using virtual threads. Virtual threads are so lightweight that we do not need to pool them anymore. Virtual thread runs on top of a platform thread. Many virtual threads share the same platform thread. Let's see how we can create and execute a virtual thread. I'm having my IDE with a Java project. This is how we could create a virtual thread. On executing this main class each time, both of the virtual threads are running in either same worker thread, that is platform thread, or different threads. Thanks for watching. If you enjoyed this video about Java virtual threads, smash that like button and don't forget to subscribe for more programming content. Hit that notification bell so you never miss an upload. Want to share your thoughts on virtual threads? Leave a comment below and let's discuss.